How was student life?
Pardon?
Did you take part in the student life at all, or not really?
No, you know, the married students, pretty much, you know, we were, and graduate students at that were
Yeah.
beyond that.
But did you learn what you wanted?
I learned, I learned what they offered that I thought I wanted, but as a matter of fact, there wasn't very much, you know, the electronics of how a computer works. The very, very elemental early start about specialized computer programming things that you learn. The computer programming was such an infant state, and since that computer we were building never got working, I didn't have any experience at all in programming a computer. I kind of got the PhD.
What did you get? What PhD? It was electrical engineering.
With a computer minor, computer systems minor.
And you also got some patents, didn't you?
Oh yeah.
What was that for?
Well, this, you know, what would I do for a research project as they have to have when you get to a PhD? And, you know, the things about using a computer for this or that, if the computer wasn't working, you couldn't do that.
Yeah.
And then one day, sitting in the study hall, I was thinking about you need to have things that will stay in one of two states. It's like flip or flop, and that can be changed very quickly in a computer. So if you try to do that electronically, and for some reason I remembered, oh, one of the tricks that we learned when you're tuning a transmitter or something is there's little bulbs that have two electrodes in them, and they're filled with low pressure neon, for instance. And they're used a lot of times for little indicator lights to say when something's on or off, because it doesn't take very much current or power to light them. And one funny thing about it is, if you hold them up near the transmitter's antenna and you start tuning up the different stages of it, when it got powerful enough, it would all of a sudden start glowing. And you could tune it instead of by meters that might oftentimes aren't very easy to see, until that gets the brightest, and you know it's got all of this more power, see? And I happened to notice one day tuning that thing that, oh, it bright up, you know, you have to get about this much signal power before it bright, but then if you wanted to quit it, you'd have to get way down to here the power before it go out. And then in this state, in that range, whatever it was would stay. You know, if it weren't on, it would stay on. If it was on, it would stay on. And I just realized in the computer time, well, that's the kind of bistable thing that you're looking for in kinds of electrons. So I wonder if that could be used. And then I thought of something of having just a long hollow glass tube that was vacuum and low pressure that, and I put electrodes over there and put this strong electronic radio signal across, and you can blow them up. But what if I put a signal there that was just big enough to maintain the glow? Then I could have another one I would turn on, another one, and then back and forth. So this pattern could move a glow along the tube, and if there hadn't been one to start with, it wouldn't go. So you can move a pattern of glow, no glows,
All right.
which is what they call a binary pattern. And this would be a shift register, which is one of the components used in a computer. Oh, why don't I try that? So it mean I had to learn about the gas and the discharge and a lot of things that happened in there. And somebody mentioned partway through when I had it working that, hey, you know, there may be some patentable ideas in there.
Yeah.
So they pointed me to a patent attorney, and he got interested and said, well, we can cooperate. You know, if I didn't have enough money to pay for the patenting, so he said, we'll be co-owners of it if he does it. So it ended up about 12 or so patents about different kinds of parts of that phenomenon, but they didn't turn out to be worth anything, I think.
What did you talk to anyone about your crusade when you were there, about your ideas?
Yes.
To who did you talk about? To whom?
Well, I mentioned it once in a while to the graduate students.
And what did they think?
Oh, it just sounds weird because who can afford a computer? I said, well, they're not always going to be this hard. They'll be cheap and stuff. Oh, well, gee.
Did nobody think that that computers would become very important?
Absolutely not.
Really?
Absolutely not that they'd be,
What do they think they would be used for then?
computing, for how you solve big problems and complex things.
No,
And
they. Because
Pardon?
your fellow students, how did they see computers in the future? How did they think they would be used?
just to be used as doing computations for some different projects around that needed that. There were people at the university who were wanting to use it for making up traffic, studying traffic. They were transportation engineering students, and so you could make a model of the computer. You could have the computer programmed to pretend that there were this many cars and the spacing and traveling this fast, and
Yeah.
and what would they do, and to try to project on this. And others that wanted to learn more about how different kind of radio waves would propagate and reflect.
So it's very different. Very different.
Very, very different.
Yeah.
So I found I just it didn't get me anywhere at all to try to explain what I was interested in.